So we'd like to do number 70 out of the chapter 11 review. So we've got a log of the square root of x squared y cubed over z. And we want to kind of simplify this thing. Okay, so in one sense this is simple. So
Is this the one where I'm taking that and then minus the z?
first we have to do something.
Okay.
So the reason we have to do something first is we don't have a log rule for the square root of division, right?
Okay.
So I have to either re-express this as division or deal with that square root. Either one is fine. They both work the same way. So either one's,
The same.
yeah, they both work the same way. One amounts to do the power log rule first. The other one amounts to do the division log rule first. But you're going to have to do both rules in both procedures, so it doesn't matter. So I don't care. Do you want to see both ways? Okay, so first things first, maybe let's try to deal with it as division. So can I re-express this thing in a way that I've got a division with no square root on the outside of it?
But it's not 1/2 log x squared y third.
That's the other way. Good call, though. So I could take the square root of the top and divide by the square root of the bottom, right? This is one way that I could consider this thing. And now this is division. So now I have a log rule that applies, right? What does it say?
Gotta minus the log.
Yeah, that the log of a fraction is the log of the top minus the log of the bottom, right? Okay, so I'm applying a log rule in here. Right? And really this is the division log rule that I'm applying. So I get log of what?
To divide it, x squared y to the third minus 2.
Square root of x squared y cubed minus
square root
log
of
of z squared.
You guys see that? It's got to be the log of the top minus the log of the bottom. Doesn't matter what's in the top, doesn't matter what's in the bottom. The whole thing. So log of the whole top minus log of the whole bottom. Okay, now I have a problem in that I have square roots in here. I would like to take them out. Right?
We don't want to raise the log?
I don't have another side.
Okay.
Right, this isn't a solve, so I don't have the other side to deal with. I just have the one thing I'm simplifying. I can't just willy-nilly put everything in the exponent of a 10 because I don't have an undoing for that. Right, I did something and it's no longer equal to the thing I started with. You guys all see that? Yeah, I want to think about the square roots as half powers. Why is that advantageous? Why is that?
Because it's the rule.
Yeah, because they have a rule for powers, right? So I could say, all right, this is the log of,
So it's 1/2 x squared y third
let's write it first and then we'll. So x squared y to the third,
to the 1/2
all to the 1/2 power, minus the log of
The square, x c to the 1/2.
z to the 1/2. Perfect. Cool. All right, now what?
Now you put 1/2 on the left.
On the left. Okay, so I take these guys, right, the powers, and I pull them down front, right? Because I have a log of some junk to a power. Doesn't matter what the junk is, but as long as all of it has a power on it. Okay, so that. Okay, so that's really the log rule about powers, right? That's the power log rule. And I get out of this what?
1/2 log x squared y third minus 1/2 log
Perfect. Okay. Now, which pieces are as simple as they're going to get, and which pieces can I keep playing with?
The log of z is simple as it's gonna get, the left side can be, powers can be taken out, and then it
You have to do like
You gotta do
separate
another
them
log
first.
to raise that up.
Okay, so you guys are seeing that this log here needs some combination of the multiplication log rule and the power log rule, right? Which one do I have to do first?
That's what makes the power rule. X, Y,
Yeah.
I have to do the multiplication rule first because the power rule only works when it's all the stuff inside the parentheses to a power. This is half the stuff to the second and half the stuff to the third. I don't know which one to take out front. You guys see that?
So you distribute the half of them?
So I should say, okay, this is 1/2, and now this whole thing, right? This piece, oops, wow, bad bracketing. This whole piece is going to turn into something, and then I'm going to have a minus 1/2 log of z. That's as simple as that piece is going to get. Right? So I left that piece alone. And now, what's the thing I'm using here?
log of x squared minus, or plus log of y.
So I get log of x squared plus log of y cubed. What rule did you use for that?
The multiplication.
Yeah, that's the multiplication log rule. Cool. Now, what do those parentheses indicate I should do?
Multiply both logs to the 1/2.
Yeah, I need to distribute my 1/2 through. So I've got 1/2 log of x squared
Plus 1/2 log of y cubed.
minus my 1/2 log of z.
Now you can take the power to
And now I can pull the powers out because the whole argument, right, everything in the parentheses is raised to that power. So that 2 can come out and this 3 can come out. You guys see this? So what do I get when they come out? I've got,
Log of
the log
x,
of the left.
why?
because 1/2 times 2 is 1.
Oh, cool. The 2 that I pulled out and the half that was there canceled, right? So I get log of x plus
3 halves,
3 halves
log of y,
log of y
minus 1/2 log of z.
minus 1/2 log of z.
Should you put the log of x plus log of y in parentheses and then minus? Or
Does it
that-
matter?
No, it's just,
You could. You certainly could. But does it matter?
not necessarily, but,
Why not?
well, because when we multiply, it's still gonna, once you divide and multiply, it's still gonna end up on top, but it just, for me, it keeps it together, so.
So you want parentheses like this.
Yeah, I usually do that because that way I know what's a group.
Okay. So you guys all see this? Cole's saying maybe we should throw some parentheses around this stuff because we were kind of treating that as a group before, right? Do I need those parentheses? Why not?
Because you're done.
It's not a general.
Okay, remember, sometimes when I'm done, I need the parentheses.
Because you can see that it's its own thing, so you don't need the indicators there.
What do I use parentheses for?
Order of operations.
Yeah, I use them to kind of push things up the order of operations ladder, right? This was addition in here, right?
Yeah.
Does that addition need to happen before this subtraction?
Doesn't matter.
No, it doesn't matter, right? Those are all at the same level of order of operations. So I don't really need those parentheses. They're not bad aesthetically.
Okay.
You guys see that? Those are solely aesthetic parentheses. Cool?
Wait, I use them on like the adding and subtracting. I use it like this is being multiplied then being divided by this. So if
Oh,
I was
yeah,
to, like,
sure.
go backwards or forwards.
Yeah, so if we wanted to turn this backwards, that maybe would be a good way to reverse our steps. Yeah. You guys see that? Do you want to see the other way with the half first?
This is done.
Yeah, this is done.
Oh.
So this is as simple as you're going to get, except maybe for the aesthetic
Does
parentheses.
this inference is bigger than the answer, than the question?
Yeah, so simplify was a weird instruction for this. The book gave slightly more specific instruction. Cool.
So it should have been like, break this down into its most basic form.
Yeah, they have a paragraph instead of the word simplify. So if we wanted to do this the other way, we would just think about this from the beginning as log of x squared y cubed over z to the 1/2 power. And then we would take our 1/2 out first. Then we'd have the log of x squared y cubed over z. And then we'd start doing a bunch of log rules to this thing. You guys see that? You'll get the exact same thing in the end. You'll just have to distribute the half. What's up?
Can we give our answer like that, like 1/2 parentheses and
Sure.
stuff and stuff like that?
Yeah. Cool? Questions, things?
That way seems a lot easier. Or something.
And then steps, it seems like it.
Sure. Yeah, because you're not having to track the 1/2 through the whole time. Yeah, that's not a bad. These are the same procedure in a different order, right?
Yeah.
It doesn't matter so much. The thing I want to highlight is that this means that I'll distribute the 1/2 at the end. This guy means I distributed the 1/2 early. It doesn't matter. They're the same thing.
After you distribute that, are you done?
You'll have to do all the same log rules we
Oh.
did over here.
Okay.
It's not going to save you tons of time.
Yeah.
We just already did most of the work.
Okay.
Cool?